0 radians, and if we go all the way around, we said it's 2 pi radians, and if we go to 180 degrees, we know we are at pi radians. Now, the next ones that you want to fill in are the ones that are going to be halfway between those two. So halfway between 0 and pi would be taking pi and dividing it in half, so it would be pi over 2. So this distance would be pi over 2, which is 90 degrees. And so now if we know this is pi over 2, then this is going to be 2 pi over 2. But you can simplify 2 pi over 2 to just be pi. So if we go around another distance the same, this will be 3 pi over 2. So down here at the bottom where you see 270 degrees, that's going to be 3 pi over 2. And then of course, if you went another distance, you would be at 4 pi over 2. But we know 4 pi over 2 is the same as 2 pi, which puts us there. So essentially what you can see that I'm doing is I'm counting in fractions, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. And so then you can easily fill those in. And all I really had to remember was this or this, right? The circumference of a circle. So that's going to take care of the ones on the quadrants, right here and here. Okay, so now we can go and fill in the other. So the next thing that I recommend doing is all of your 45-degree angles, because all of your 45-degree angles are just going to be dividing that same distance that we just did, dividing that into a half. So for example, right, if you have this distance from 0 to pi over 2, and you take half of that, well, pi over 2 times a half is going to give you pi over 4. So now we know this distance right here, or this measure in radians, is going to be pi over 4. So from here to here is pi over 4. So just to make those stand out a little bit more, I'm going to make them all blue because there are quite a few lines here. Okay, so maybe that's sufficient enough. So all of those in blue are going to be your pi over 4s, but see, we also had the distance from here to here that we considered as well, because we know that's cut in half. So I'm going to also make those stand out, and so we'll make the axes, we'll make those orange because we've already talked about those. Okay, so now you're just looking at the blue and the orange. So from here to here is 1 pi over 4, but if we go here to here, we're at 2 pi over 4. But we know 2 pi over 4 simplifies to pi over 2. But you can keep counting in this manner. So this is 3 pi over 4. So we're going to label the coordinates for this one to be 3. Let me make that a little smaller. 3 pi over 4. And then we have 4 pi over 4 is just pi. And then 5 pi over 4 would be the next one. And then 6 pi over 4 would simplify down to that. And then from here to here would be 7 pi over 4. And then finally, you're going to end up here to here, and it's 8 pi over 4, which once again is another way to simplify down to 2 pi. Okay, so now you have all of your pi over 4 multiples, and you have all the ones that are actually on the axes. So the next one we're going to look at is our 30s and then our 60s, but I'm going to make those different colors as well because we know eventually they're going to have different reference angles. So what you're going to do to figure out how to label that in terms of radians is 30 degrees is if you go all the way around, you're really taking pi, and we're now looking at the white and the orange, so you're going to ignore the blue. So if you do the white and the orange, you can see that you're dividing pi into 6 pieces, right? From here to here, from here to here, here to here, and like that. Okay, so there's your 6 pieces that you're dividing it into. So we're going to take pi, and if you divide it into 6 pieces, it's going to be pi over 6. So that means 30 degrees is going to be equivalent to pi over 6. So let's make all of those stand out by, now I'm making just these ones pink because these ones are going to have the same reference angle.